Okay, class, so today we're going to be talking about frequency tables. And frequency tables are just a type of way that we can look at data. So I guess if you really want to title up here, we can title it up here at the top as frequency tables. And here's the thing. I don't know that you writing down every single thing that I say is going to help you notes-wise or anything like that with what we're looking at. This is one of those things where we need to have a clear understanding of what we're talking about so that we can interpret information that we're given. So you might just kind of need to write down or take some notes on some things that you might want as reminders and some sort of key hints I'm going to give you for calculating some of these values. Okay, so in this frequency table up here that we're looking at, we have some information about bald men. Okay, and we're deciding whether or not someone is bald, yes, bald or no bald, and then how old they are. Okay, so what their age is, and then whether or not that they are bald. Now, when we are looking at this is just one way that we can present data. But frequency tables are typically used to present data when we have multiple categories spread out over a different set of multiple choices. So maybe I want to decide what Westfield High School students' favorite ice cream flavor is, but I want to break it down and see if it's different for freshmen, sophomores, juniors, and seniors. Okay, so I'm asking freshmen, I'm asking sophomores, I'm asking juniors, I'm asking seniors, and then I'm also going to have all my different ice cream flavors. That's when a frequency table sort of helps us. It allows us to look at sort of various situations. So here we're looking at men who are under 45, right? Or men who are 45 or older. And then we can interpret some information from this frequency table. Okay, so the first question asks us, how many men were in this sample? So if we were to know how many men were in this sample, we simply need to go through and we need to total up how many men were surveyed. Now recognize this is, oops, I crossed that out. This is all about bald men. So the whole entire sample is men, so we're not limited there. So every single respondent needs to be counted. So we're going to take our calculator and we're going to add up 81 plus 97 plus 20 plus 31. And so we know 229 men were sampled. Now, some frequency tables will be nice and they'll already have that total for us, but that is not always the case. Sometimes we're going to have to do that work on our own. Okay, the next question in this then says, how many men in this sample are not bald? So whenever it's asking us to look at a question, we want to find the category that it's talking about. So this is talking about not bald. So here's our no. We then want everything that's still in that row. Okay, so once we find our no, we're going to go everything across. So we have 97 and we have 31. So we know in this we have 128 men who are not bald. Now, that's just one way to talk about data is by just like looking at the totals that we have, right? We could say that there are 20 men who are 45 or older who are bald. But typically it's going to be more useful for us to look at a percent, right? Because that percent tells us about the whole, right? Percents are what we're more used to talking about. We can also do things like calculate a percent. So our next question here says, what percent of the men less than 45 years of age are bald? And here's the first trick that I think is sort of important for you to know. Whenever we want to calculate a percent is always a fraction. So that's the first thing we need to know. If it's asking for a percent, we better be writing down a fraction. Okay, then I always find it easiest when we read the sentence to see what is happening after after the word of. Okay, so what percent of the men less than 45 years of age? Whatever is coming after the word of is going to be what goes on the bottom of our fraction. Now, obviously, it depends a little bit on the English language and what we're talking about. So it could be of, it could be have. Okay, it kind of depends on what the topic is that we're talking about. And then whatever we read after the word are, again, English language could be is. Okay, again, that depends a little bit on what the discussion topic is about, is what's going to go on the top of the fraction. Okay, so after the word of is men less than 45 years of age. So we need to calculate men less than 45 years of age. So here's my under 45 column. Again, I'm going to do the whole thing. I don't have anything else to limit it right now. So I'm going to do 81 plus 97. So in this survey, there were 178 men under 45. So that's going on the bottom of my fraction. 178, just kidding. I almost wrote the wrong number. Okay, then after the word are is bold. So we're looking for men who are bold. So that's a yes, bold. So I'm going to go to my yes and go all the way across here. And I want the intersection. Okay, I want where those overlap. So I want 81 on the top. Now, I have a fraction, but 81 over 178 is not a percent. Okay, that fraction allows me to calculate the percent. So now I'm going to pick up my calculator and do 81 divided by 178. And my calculator is saying 0.45505. This is still not a percent, right? To turn a decimal into a percent, we need to multiply by 100, which is the same thing as moving the decimal point 2 places, which is probably what a lot of us know to do. And so we have 45.5%. I always want you to round to at least that 10th position. Give me one decimal point. So 45.5% of the men less than 45 years of age are bald. Okay, so let's look at our next question. What percent of the men 45 or older are bald? So now same statement, what percent? We're reading the word percent, so we want a fraction. After the word of, the men 45 or older. So let me erase this highlighting I did up here. Okay, so men 45 or older. So that's this column. I have nothing else to limit it with, so everything that's highlighted goes on the bottom, which is a 51. After the word are is what I'm going to put on top. So after the word are is yes, they're bald. So now I want my yes, bald column, row, I guess, which my overlapping area is now 20. And so that's the number I'm going to put on top. So again, in my calculator, I'm going to do 20 divided by 51. I get 0.3921, blah, 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 blah. But again, I want that as a percent. So this gives me a 39.2%. Okay, next question. What percent of the men are bald? So we know we need a fraction because we read the word percent. And I need a fraction of the men. So of the men means of this entire sample because they are all men. Good news, we already calculated that. So I have 229 on the bottom. So right now, of the men, this entire table is counting so far. I've used everything. Okay, now I need are bald. So now I need my yes row. And I want where they intersect. So I have two things that intersect here, which is the 81 and the 20. So I'm going to add those up. So I'll get 101. So to calculate my percent, I'll divide and then multiply by 100, which gives me a 44.1%. Okay, so I want you to look at this next question. What percent of men 45 years of age or older are not bald? And I want you to come up with an answer. So when we look at this, here's what we should have done. Okay, so for this one, again, if we are looking after the word of, men 45 years of age or older, so 45 years of age or older, so that gives me 51. That are not bald, so now I'm going to my not bald column, and I want 31 on the top. So when I take that 31 and I divide it by the 51 and turn it into a percent, I get 60.78. So if I'm rounding to the nearest tenth, I should have chosen the 60.8%. So we have another table down here that we are going to look at just to sort of show a new representation. This is another frequency table, and this table gives us a little bit more information and is actually a little bit more helpful because they were super nice and calculated the totals for us. So in this frequency table, okay, there was a proposal given to increase the length of the school day. And the school took a survey, a random sample of students, okay, and asked some males, asked some females, and looked to see if they opposed extending the school day by 30 minutes, if they supported it, or if they didn't have an opinion at all. So question number one, how many students were sampled? For this one, we definitely should have picked 200, and we didn't even have to do any work because that total is already listed for us. How about what would we say for what percentage of males had no opinion at all? So if we want what percentage of males, okay, so we're going to our of males column, which is 110, had no opinion at all. So no opinion at all is here. They overlap at 20. So when we do that 20 divided by 110, we get an 18.2%, right? When we need to make sure we round, and when we round correctly, we get an 18.2%. Sorry, that's kind of messy. On our next one, what percent of females did not oppose? Well, when we look at this one, if we want the percent of females, okay, of females, so again, this one's really nice. It's got the total for us. So our female population is 90. Did not oppose. So if we want the ones who did not oppose, we are talking about people who support and people who have no opinion at all. So we have an overlap with the 40 and the 10, right? Here's my intersections. So I want 50 on top of this. When I take 50 divided by a 90, I end up with a 55.6%. Now, this last question is a little bit trickier. It says, if the total school has 1,200 students, how many students would be in support of increasing the length of the school day? This is where we want to make an inference. This is where we can make an educated guess. So the first thing that's probably going to be helpful to us is if we know what percent from our survey were in support of increasing the day. Okay, so we had 200 students total in our survey. Okay, and the number of students who were in support, right? It tells us right here in this column is 80. I know that 80 out of 200 students were in support, so I'm going to calculate that percent by dividing, and I get 40%. It's a straightforward even percentage. But now I don't want to stop at that percent. I want to take that 40% and I want to apply it to the entire school of 1,200 students. So how many students do you think, knowing this information, will be in support of increasing the length of the school day? Well, we should have taken the 1,200 students and multiplied it times 40%. So if we're taking 1,200 times 40%, right, we need that as a decimal. So we need 1,200 times 0.4. And when we do that, we get 480 students. Now, does that mean exactly 480 students will be in support? No. But is that a super educated guess based on the data that we have? Yes, it is.